all do this together. So it's going to make sense.
I'm ready when you are.
And that could be done through walls.
Okay, everybody.
Wow,
that's great. Welcome everybody to the February 2017 Security Things Meetup. 2018 Security Things Meetup. I'm Paul Roberts. I'm one of the organizers of Security Things Meetup. This is my friend Jeff Fuller, who is the co-organizer. And thanks everybody for coming out. This is our first meetup here in the WeWork facility. And so before we get going, I want to give Stella a chance to come up and talk to you just a little bit about WeWork.
Hi everybody, I'm Estelle. I'm on the team that operates this building. Carter's actually still here, he's our manager, he's in the back. But I have worked at WeWork since the summertime of a huge affair, and we actually got the chance to hear the CEO of MeetUps also speak, because two companies are now one. So definitely very happy to have you all here. If anybody has any questions or wants to take a tour at any point, I'm happy to show you the building. We have tons of different levels of membership. Some people come to us and they just want to come in once a month and use us for conference room space and events. And then there are massive companies that take up floors of our buildings. But it's definitely a fun community. We have 6 buildings in Boston, and we will have 10 by the end of next year. No pressure to get office space, but definitely happy to have you on this occasion. If anybody has any questions, feel free to tag me in. Thanks.
Thank you, Scott. The other thing is that there's a sign going around with names and emails on it. I'd like to get a sense of who's coming to what meetings, and so that is in front of you. Sign it and pass it along. How many people here have never been to a Security Things meetup before? Oh, okay, great. Okay, so since we've got a manageable group, would it be okay if we just play around, and because there is like a networking component to this as well, ideally, and just say who you are, and if you want to, who you work for, and why you're here, what your superpower is, and so on. Okay. My name is Paul Roberts. I'm the editor-in-chief and publisher of the Security Ledger, which is a cybersecurity news website. I've been writing about cybersecurity for 15 years. Started Security Ledger a little more than 5 years ago. Started this group about 3.5 years ago. And we've been meeting more or less monthly ever since. And so we generally meet the third Tuesday of every month, and we tackle a broad range of issues kind of in the constellation of Internet of Things and security. That could be embedded device security, it could be application security, it could be endpoint security, it could be identity, it could be cloud. So it's not all Mirai botnet. There's a wide range of topics that we try and undertake to kind of help some of you guys who are out there working in companies that are tackling these problems or interested in retooling and retraining to get into this industry to orient yourself. Okay, I'm going to go to this gentleman, Paul, right here.
Hi, my name is Paul Brown. I live in Rhode Island. I work for the Data Agility Group. We're a niche provider of data migration services, both headquartered in Irving, Texas. And I'm here to continue growth, learning, and bring some information back to my own community, faculty levels, and such.
My name is Leah. I work in the ERP space, HR, procurement, financials, specifically Oracle. I'm looking for opportunities to move on to other things. My involvement with security is data security, SOX, all those the compliance.
Sarbanes-Oxley.
Well, yeah.
Yeah.
And sure.
Hi everyone, I'm Rodney Hess. I'm with Beachwood Software. We're just on at the edge of the North End over on North Washington Street. We're involved with, from the IT perspective, the EdgeX protocol and the Open Connectivity Foundation. And we were just here last Thursday with a meetup that was talking about edX. So I'm happy to come here and hear about things over here. So,
What meetup was that? Was it like an edX focused meetup?
no, it's the open source IoT group.
Okay, all right. I should reach out to them.
I'm Vincent. I work in healthcare. H. That works in behavioral health. I work as a cybersecurity analyst, developing an incident response plan and incident response workflow for the company and how to protect the assets. What brought me there is I'm interested in security.
I'm Fabrizio D'Angelo. I'm a student, computer science student at UMass and I'm working with Draper on the algorithm software division of the training program. And I hope to one day get into cybersecurity.
Hi. My name is Maxine. I'm a former NSA linguist. I'm interested in cybersecurity.
Hi, my name is Cody. I work for Fortland. We do 3D printing. If you want to talk about a third type industry, come chat with me.
You say IoT and security is hype?
Hi, my name is Greg, and I graduated from UMass Amherst with a Bachelor of Science in Computer Science, and currently I'm taking some courses through DDS, some cybersecurity courses, which are done by Rochester Institute of Technology, and so I was just kind of curious to come here and see what some of the people in the industry were talking about.
Hello guys, I'm a student at Northeastern University pursuing my master's in cybersecurity. So I'm here just to learn and to bridge the gap between academia and industry because there certainly is a gap. So I'm here to learn more about this.
You said Northeastern?
Yeah.
Hi, I'm Rob Castillo. I'm a security architect and doing support consulting right now.
Hi, I'm Jeff Labby. I do some consulting in the IP networking space, and I focus on the IoT discussion. An interesting topic, sure so.
Hi, I'm Jake. I'm a recent college graduate from Green Bay, and I'm just kind of interested in the topic.
I'm Daniel. I work in embedded software. I'm interested in security in general, but also I'm starting a project where I need to talk to things that use DDS, so I'm pretty interested in this part topic in general, in particular.
Hi, I'm Robert. I'm a chief software architect for UDP Financial Software Company, and that gives me an obvious interest in security topics generally.
Anyone else? I think that's it.
Okay. So we've forced you to network. Even those of you who have come here, not wanting to network, you've got network. Other orders of business would be, so this is our first meeting here. We are talking with companies as well about doing meetings at different places around town, Kendall Square. I'm sure we'll do more meetups here as well. But obviously, if you are working for a company and you think the company might be interested in sponsoring a meetup or have a subject matter expert that they'd be interested in highlighting, reach out, let me know, and we will be sure to follow up with them. Only other thing to say is that we're doing a little bit of fundraising. So for a Meeting Owl, so we can kind of enhance our online, because we're streaming right now, and we are organized. I am kind of raising a little fund for a Meeting Owl, which is a really cool device that gives you a very high quality streaming experience if you're watching it online. So if you go to the webpage and contribute, I think we've raised like $50 so far, which is pretty good. but we're saving up our pennies towards a meeting and also take care of that. The only other thing I would say is Security Thinks Forum is going to be coming up in June 19th. It's going to be, and I'll send more information to the group about this, but it's going to be happening in conjunction with BTC Liveworks down at the on the waterfront. We're going to have a whole day of IoT and security content, kind of interesting talks and panels and stuff. So just keep that on your mental calendar. Okay. You ready, David? I'm ready. Okay, great. So without further ado, let me introduce our main speaker, who is David Seltz, and he is Regional Field Application Engineer Manager at RTI. And I'm going to let them tell you more about yourself and your background. We are going to do the Q&A after the fact, but I'm sure he's happy to take questions today.
Hi, this is my first meetup. I think this venue is totally cool, so I'm sort of psyched about doing this. I'm the local field engineer for RTI. RTI makes a communication middleware called DDS, and I'll talk about that quickly over in a few minutes. I'm located outside of Boston. I'm also the FAE manager for the Northeast for RTI. I think someone went to ULowell. I graduated, got my master's at ULowell, and I've been in the embedded industry, oh my God, 25 years. Jeff and I used to work together years and years ago. So, before I start, please feel free to interrupt me at any time. And if you want copies of the slides, I'm glad to give them out, so don't feel like you have to write anything down. I'm going to talk about RTI just very quickly, give you a little bit of background. I'm going to then go through DDS, so you know what that is, quickly. But the focus of the presentation is going to be security. And I'm going to talk about a standard which is called DDS security. And then we'll have time for questions, but like I said, please feel free to interrupt me and ask questions during the presentation. So Real-Time Innovations, my company, is based in California. It's a privately owned company, it's a small company. Very academic. It came out of Berkeley. If you look, there's a lot of PhDs and master's degrees, etc. It's sort of a nice place to work, still has that small company culture and feel. We're the market leader in DDS. So just to let you know, DDS is a standard. There are a lot of other implementations out there. There's also an open source version of DDS. And we actually, when talking with our customers, let them know that because that's an advantage. There's no vendor lock-in. They can go to open source. They can go to other vendors. It has a very good ecosystem. We have over 1,000 different designs currently out there running DDS, and I'll talk about some of them very quickly later. And we're very active in a lot of different consortiums as well. It was sort of neat that we're listed amongst some of the biggest companies in the world in regards to our influence in IoT. You can see we were cited by Forbes as being one of the 10 most influential IoT companies. And it's pretty good for a small 150-person company. And I'm not going to go through each one of these, but we've been doing okay lately. So what is DDS? DDS started back in 1912, the standard, and it really coincided with the attack on the USS Cole. I don't know if you guys remember that, but this was in port in Yemen, and terrorists blew a hole right in the side of the ship. Back then, the Navy used a centralized architecture for their communication. I believe it was Corva-based. Well, that attack knocked out the centralized server and knocked out the communications for the whole ship. ship was dead in the water. And even though it was really somewhat seaworthy, it had to be towed back into port. So at that point, the Navy mandated that they use a distributed communication architecture. And RTI, my company, and Thales worked together, or Thales, excuse me, worked together to create the DDS standard. Now the DDS standard is owned by the Object Management Group, which owns a whole bunch of other standards. They own Corba, for instance, and DDS Secure. You can find DDS on the edge. There are very small versions of DDS to fit in memory-constrained devices. And then DDS is running all the way up in the cloud. And I'll talk about that a little bit. And over 1 million different devices are using DDS, and I mean the standard DDS. By the way, for now on, this is going to be vendor neutral. I'm talking about the DDS standard, I'm talking about the DDS secure standard, not RTI's implementation of it necessarily. You can find DDS in autonomous vehicles. Almost every single Navy surface ship today is running DDS. It's in unmanned vehicles, it's in underwater UAVs, it's out in space, it's in all sorts of medical devices and all sorts of industrial applications. So just give you some quick examples of where DDS is used. This is the launch control system that is being used at NASA, the KSC launch control system. 3,000 different points, applications communicating with 400,000 messages a second. So it gives you an idea of how huge some of these applications are that have to communicate and how complex these problems can be. DDS is running in the Grand Coulee Dam, which is the largest power plant in North America. Another aspect of DDS is it runs in mission critical applications. It's a very solid technology and been running in things like cars and automotives and dams and things that need to work every time. And then it's running in the Seltz. And in fact, that was one of the first ships it was implemented in way back. It's been been worked on for years and years. And originally they just wanted DDS in 10% of the ship, and gradually we've taken over a lot of the different systems on the ship. So what is DDS? You guys probably are used to sockets, TCP, IP, that type of thing for communication. And the problem with that, it's all point to point and it's ad hoc. You have to know everybody's address that you're communicating with. So it means it's hard to expand the system. Other systems are centralized. Like I mentioned, Corba is a centralized system, client-server type of system. But the problem is that everything has to go through that central server. So it's slower, and it's not expandable. The more endpoints you add, the slower the communication becomes. Also, it means that there's a single point of failure, as I said before. So with DDS, we take all of the information that was in that central server and we put it on every endpoint. So now, all the communication is direct point to point. There's no single point of failure. And it's a very dynamic system. It's easy to add extra data buses, extra endpoints, and even communicate between data buses. So I was going to show something on my computer, like a quick little demo. I'm not going to do that. But afterwards, if anyone wants to see, I have a DDS secure demo and a very quick little small DDS demo I can show you guys later. So what are the advantages of DDS? High speed, I already mentioned that. Plug and play flexibility. Endpoints can come into the system and leave at any point. Oops. No single point of failure, and it's a standard, as I said before, so you don't have vendor lock-in. The standard defines the API, which means that you can port your code to other versions of DDS very easily. And it can, it defines the wireline protocol, RTPS, so my version of DDS can talk with somebody else's. Supports all different languages, all different operating systems, so you could have one system that is running on Windows on an x86 platform using Java, talking with another system that's running on Linux, on ARM, using C++, and they talk together perfectly. DDS takes care of all the translation for you. DDS, as I said, goes from the edge to the cloud. And an example working today is in a hospital. GE Healthcare uses DDS in the patient room, connecting their devices to monitor patient symptoms, to the nurses' stations, all the way out to the cloud. So DDS can be used in, from the edge all the way to the cloud. And then just quickly, the type of application that uses DDS has all different types of data that are being communicated at the same time. So you could have video, which is huge data packets, but they come infrequently. You could have radar, which is less frequent, smaller packets, but you could have control data, which is coming much more frequently. And DDS is able to handle all those different types of data and communication. Okay, so that's it with DDS. Any questions or anything before I go on? So now we'll talk about security. So DDS Secure is a standard owned by the OMG. It's fairly new. The first beta came out around 2014, and they just released this past fall the 1.1 version of the specification. These are the companies that were involved in the DDS specification, the DDS Secure specification. So you see there's a lot of big names that really care about DDS Secure. These are DDS users who needed a secure version of DDS. So typically, when you want to secure your system, there are different levels at which you can do it. You could do it at the system boundary level, usually using access control. You could do it at the network transport level, that's usually using DTLS or TLS, where you're securing the transport. But with DDS Secure, we secure the data itself. So why isn't TLS or DTLS enough for your system, enough to make sure that your system isn't hacked? Well, the problem is, first of all, it's inefficient. When you're using TLS or DTLS, you're securing your whole system. And that can be very inefficient because there is an overhead to latency and throughput when you add security to your system. Secondly, there's poor latency and jitter because both of those technologies are built on top of TCP, which has its own latency issues and jitter issues. It's not scalable because multicast is not supported. And multicast allows you to send data to as many endpoints as you want with one send. So if you have to do it serially instead, you have a much less efficient system. And it requires generally a robust network. And we run on a lot of applications that are underwater that don't have a very robust connection or in space, etc. So you have to be able to run on top of networks that aren't perfect. And also, there's no inherent access control with TLS or DTLS. Usually what you have to do is stick a message broker to get access control, and now you have your single point of failure and your bottleneck. So with DDS Secure, we secure the data and not the pipe. So you're able to secure your data on a topic-by-topic basis. And in the DDS world, the topic is the packets that you're sending. So you might have one topic that's flight data, destination and arrival time. You want to make sure that's secure. You have another one with longitude, latitude. You want to make sure that's secure. But you have a third topic that isn't private. You don't care if people look at it. So you don't want to add security to it because you don't want that overhead in your system. So what type of threats are we looking at when we created DDS Secure? Well, first of all, unauthorized subscription. That's when Eve, let's say, is eavesdropping on a conversation. Unauthorized publication, maybe Truby is an intruder publishing data that she shouldn't in your system. Tampering and replay, that's sort of a man-in-the-middle attack, where you grab a message, you change it, and you republish it. And then unauthorized access to data. Sometimes an attack isn't really malicious. You can have a totally innocent application in your system mucking up the works because they're accessing data they shouldn't. So you have to make sure to secure that data and limit who can write to what applications. So let me give you guys an interesting example. There's a doctor in Boston, Dr. Goldman. He works at Harvard Medical School, and it's a sad story, but he was involved in an accident in the operating room where a mistake was made and someone passed away. And it turns out that this is a very common occurrence. In fact, it is right behind cancer and heart attack in the #1 in the causes of death in the US. And so Dr. Goldman decided he wanted to try to address this issue. So he came up with this system which is called ICE, Integrated Clinical Environment. And the idea is to get all these different devices in your hospital room talking together. And if they're able to talk together, you can put their information together and get better information going out to the doctors and nurses. For instance, one of the problems is false negatives, meaning that the nurse gets an alarm and it doesn't mean anything. Well, the nurse starts to not listen to the alarms as much, and if there's a real alarm, she doesn't run over, he doesn't run over. If you're able to combine the data from multiple devices, you get much better accuracy for all of these signals going out to doctors and nurses, and you can hopefully avoid some of that. So, as I said, right now, deaths due to medical errors is third on the list, right behind heart disease and cancer, but Dr. Goldman's goal is to move it down the list using this ICE environment. And I bring this up because the ICE environment is using DDS, and the ICE environment is implementing DDS Secure. And the reason is because in the medical world, in the hospital setting, security is vital. All of you are aware of credit card fraud. And typically you can sell someone's credit card number maybe for $10 or $15. But what's much more valuable is patient information. And typically, somebody who's stolen that and wants to sell it on the black market or gray market or whatever it's called can get more like $300 or $400 for that. So security in the hospital is key. And not just in the IT center, but all the way down to devices. They already have proven that devices can be hacked, and a group in Britain actually did that and were able to change the setting on an infusion pump, by the way. I mean, you can imagine if more insulin is given to a patient than they should have gotten. So this is something that the whole medical field is looking at very seriously right now. Here is the actual integrated clinical environment, and I actually have a demo of it running on my laptop, so if anyone wants to see it live, I can show it to you after this. But I have all of the DDS secure features plugged into it as well. So I can actually show you how all of that works. So with DDS Secure, I'm going to mention later that it is a pluggable framework. It supports encryption, access control, authentication, logging, and tagging. But all of those features are plugins, which means third parties can add their own custom plugins. And a case in point is Mokana. And Mokana makes their own version of OpenSSL and their own encryption libraries. And the key thing is their encryption libraries are FIPS 140-2 compliant, which is very important. Also, their libraries can be integrated with a trusted platform module. That is a hardware device that allows you to authenticate your system essentially with hardware rather than with software. And so in the integrated clinical environment, they're using the Mokana plugin for encryption, and they're using the trusted platform module from Infineon. So again, one of the advantages of DDS Secure is that you get fine-grained security. You determine exactly which data streams are secure. You could even, within the data stream, secure part of them and leave the other part unencrypted if that fits your need, so your system can run much more efficiently. And I've worked with a lot of our customers who use DDS Secure, and that's exactly what they do. A lot of the data, they don't care about encrypting, and they leave that alone because it really helps speed up their system. So because of that, you can optimize performance. You can choose from totally unsecured data, data that is just signed using a GMAC algorithm, or encrypted and signed. And you can do that configuration per domain or even per topic. So I'll give you a few benchmarks for DDS Secure. And by the way, this is very important for DDS customers. DDS customers care about performance. They care about a rock-solid hardened system, so reliability. And if you are going to impact their performance by adding security, they want to know exactly how that's going to impact their system. I will also say that the default security that we provide, that DDS Secure provides, whether it's the encryption, and I'll go into exactly what we do provide, is all provided by OpenSSL, and the version we're using right now is 1.0.2. So you can see that with no security, we get a latency of about just over 50. When you add signed data, you're adding about 10% to your system, maybe a little more. And then when you're encrypting and signing your data, maybe you're adding a total of 15% to your system. So you can see some of the overhead, and 15% can be a lot in some of these embedded systems. And here's throughput. Same thing, but you can see that for a 1K byte sample, it's a little bit less overhead when you encrypt and sign the data. So as I said, it's a plug-in architecture. We actually give you an SDK, a software development kit, to create your own plugins. And in fact, there are third-party vendors who have actually done that, like Makana, so they could sell to the DDS market, whether it's our customers or OpenDDS or whoever. There's also vendors that manage keys. So DDS is based on PKI or X509, which is key infrastructure. And it's the way you pass keys back and forth between endpoints to establish security. Well, how do you store those keys? How do you share them amongst your whole system? And we have vendors that is all they do. DDS Secure is transport independent, so it doesn't matter if you decide to go over TCP or UDP or shared memory or CAN bus or TSN or a whole host of transports. DDS Secure doesn't care about that. And DDS Secure requires trivial or no change to your application. So you could develop your whole application using DDS, add security, DDS Secure later, and just turn it on in an XML file. So it's very easy to add DDS Secure to your system. And it's completely decentralized, no single point of failure at all with the security. I'm not going to go into all of these, but this is the support, yes.
So if the security is decentralized, you've got 300,000 nodes sending sending things to each other. Do they have to do key exchanges with every other node in the system?
Right. So usually the key exchanges have to happen ahead of time, and you can use something like Diffie-Hellman or Diffie-Hellman elliptical curve to make that much more efficient. Because then, so there are two different ways you could pass keys around. There's asymmetric and symmetric. And symmetric means you create a secret word, and then you can create this special key, and that can be shared amongst all the endpoints communicating a certain topic. And by the way, all of this becomes encrypted. So these keys are quite often readable to begin with, so you can configure your system, but you encrypt them before you use them actually. So in any case, X509, PKI-based authentication, that's very standard in the industry. It's used by your web browser today. Access control uses a governance file. I'm going to show you that in a little while. Cryptography, we support AES 128 and 256 and GMAC and GCM and data tagging and data logging. I won't go into those right now. So what happens in a typical handshake? Usually you have a domain participant, that's just somebody communicating. You have to authenticate him. That means you make sure he is who he says he is. Step number one. And that's usually when you use a certificate of authentication to do that. And you have a certificate authority vouching for that person. He is who he says he is. What access does he have? Is he allowed to communicate this particular data? And then you authenticate the remote domain participant, and that's when you do that key exchange that I mentioned. And generally the way it works is you have a public and a private key. You give them the public key, they encrypt their data and send it back to you, and the only way for you to decrypt that is using your private key. So that is what gives you your security. And this is also where Diffie-Hellman comes into play as well. And then you establish a shared secret with KX keys, and that's that synchronous keys that now you can share amongst multiple endpoints. So that's generally how it works. And this is just talking about what I already mentioned. You have a permissions file, a certificate, and a private key. Your permissions file has that public key that I mentioned as well built in. And you talk with a certificate authority. It vouches for who you are. And that's how you communicate between two endpoints.
But questions now, questions later. Now, the architecture parallels Kerberos in a sense, and the difference being that leases with Kerberos expire. How, if the system is compromised with one of the keys, how broadly does that compromise affect the system? The control mechanisms there. Of course, we all know if you give the key away, you've got trouble, but people get keys away.
Right. So it's an excellent point, first of all, and it's exactly what happens in the system. What happens if that private key gets compromised? The public key they give out all the time. That's not a problem. The private key can't become compromised, and if it does, that certificate of authority that I mentioned before can be revoked. They can also be time-lapsed so it can expire. And all of that is kept track of by the CA, or the certificate authority. There's also an RA as well, but I won't go into that right now.
You're agnostic about what CAs are supporting, so in essence, any DigiCert or whomever,
right,
they're assigned, you could all be.
Yeah, so that's exactly right. As long as they are X509 compliant, we're agnostic. We don't care about it.
And you like so this may be a little more philosophical and hold to the end, but there are people who do security protocol design. Who think that the degree of availability, configurability, and mix and matchableness, in say TLS is a mistake because it lets people you don't necessarily trust choose options which favor them. And the extreme case being, of course, the several different TLS downgrade attacks, which where you try to trick someone into using an earlier known vulnerable version of TLS or God forbid SSL. So is there some provision for doing more taking wired down versions or deployments of this, which are restricted to smaller sets of less negotiable components?
So, like I said, the DDS Secure is still based on a lot of the same concepts that TLS and DTLS are, namely PKI and X509. Trying to think. One of your points was that I'm not familiar with is being able to downgrade a certain version that is being used in the system. I don't know enough about that. I never heard a customer bring that up as an issue. I will say that we just align ourselves with OpenSSL, and the OpenSSL version that we use gives us our encryption, our access control, our authentication, and that is being upgraded all the time. Most customers today will use, instead of Diffie-Hellman authentication method, they use elliptical curve. elliptic curve Diffie-Hellman, which is much more complex, it's more secure, and it produces smaller keys, so it's more efficient. But I don't know about the going back version attack.
If you punch TLS downgrade attack into Google, you'll get stuff.
Oh, I totally believe you. I just don't know about it myself. Just to come clean with everybody, I'm a DDX expert. I can't claim to be a security expert. I'm working on that.
I would figure, sort of in answer to your question, it sounds like that's independent of the DDS security domain and pertinent to the application. So I would almost ask like the ICE environment, the clinical environment, if they have things that name like that. So like using the OpenSSL stack in one sense has its own inherent security risk, but it's not inherently insecure just because you just used it. So you can configure it badly in an implementation and then you have more vulnerabilities than say if you can start locking it down so that you don't even run into that vulnerability.
I mean, yeah, that's that is in effect, at least one of the questions. Is there a recommended set of minimal set of state-of-the-art components, which, for instance, doesn't have the hack functions that like SHA-1 that people now regard as suspect.
Is there another question?
So you mentioned one of the use cases was in Navy ships, but
yes.
You also mentioned certificate authorities.
Yes.
And if your Navy ship is offline and you need to reissue certificates, do you have your own self-hosted authority?
Right, so you can have certificate authorities that are public, they're well-known, and they actually charge you to certify. VeriSign, for instance, GoDaddy, I think, does it too. Those are the well-known ones, and almost any website that wants to be public has to get certification with one of those. But you can also have private certificate authorities. In fact, with DDS Secure, we give you one. But it's less secure, it's meant to be used on the intranet, I guess.
So the Hoover Dam has its own certificate authority?
I'm not sure if the Hoover Dam, and that was the, right, they're not using DDS Secure. That was the DDS part of the presentation, and they're using DDS. My guess is they are going to use DDS Secure. So remember, DDS Secure really just came out in 2014, and it's designed to be added very easily to an existing DDS system. So a lot of these companies started with DDS, and they're going to add Secure at a later time. Yes?
Why would one use DDS over blockchain?
I don't know a lot about blockchain. So blockchain is something, actually they had a blockchain discussion here, didn't you? I looked back a few meetups.
January.
Right. It isn't blockchain is a really, it's used for servers and financial transactions.
Yeah, the way, I forget his name, I should forget his name. He's an authority on it. It's not just for financial.
Okay.
It's anything.
Any transaction.
Yeah, any
It's a
transaction.
ledger where you can record
Yeah.
transactions in immutable ways, so any transaction could be.
Ah, that's interesting.
Yeah.
Makes a very nice audit trail when you need to see when something went wrong, you can get a sense of where that happened.
But there are significant latency and overhead issues with blockchain that make it not totally appropriate. It's fine for reconciling transactions if your people can afford to wait minutes or hours or even days to get whatever it is that's coming to them. But it's not really suitable for real-time transactions.
Right, and
It's totally applicable to those types of ship or dams.
does it provide access control, authentication, and encryption? I don't know enough about it. Sounds like it's really for transactional, making sure transactions are legitimate. So it's
It came out of the cryptocurrency world where they're.
right.
trying to just be sure that if you say you have a part of Bitcoin, that they know that you really do.
But if you're talking about sending data, wouldn't that be applicable here as well?
Well, for instance, I don't know
It
if
could
they,
be for the logging, for instance, or, there's pieces of it where it might apply, but then it has to, can be fast enough. It's still kind of new blockchain.
I'd only see it useful if you were going from one node to a second, to a third, to a fourth node. If you're just doing sort of one node to another node, and that's sort of the extent of the data exchange, then blockchain doesn't really drive value. But if it's migrating through a lot of different systems within this context, then blockchain might have value.
Yeah, if you need to know the whole history of a message that went around the world and back again.
Yeah.
It would be good for doing that.
right, so that seems like a little bit of a specialized case for the financial world, but even though it does have other applications. So the governance file just determines which DDS domains are protected and which aren't. Here's an example of the governance file. You can allow authentication, allow joining, discovery protection. So with DDS, there is a discovery process always running in the background, and it matches up endpoints. So DDS is totally dynamic. A joiner, someone who wants to join the conversation, can enter at a later time, and the discovery service will connect them to the system automatically. So it makes it that you can add endpoints to your system dynamically, remove them from the system dynamically. You can move things around. Let's say you want to consolidate all this different hardware into one system. You could do that very easily with DDS, because DDS discovery service takes care of all of that for you. But it means even that discovery service has to be encrypted, has to be secure. And so that's what we're talking about here. And then, of course, on a topic-by-topic basis, you can specify the security for your system. So I already talked about this, but are unidentified applications allowed in your domain? That's one of the configuration possibilities. So that would mean part of your system is secure, part isn't. Do you want unsecure applications to be able to communicate with the unsecure part of your system? You have control over that. Is a particular topic discoverable over protected discovery?
Excuse me,
Yes.
Just in vocabulary, you mentioned the configuration item for whether you effectively have public or private access. And you said to your system. You didn't say to your network.
Right.
So your system, meaning all of your nodes that have agreed to communicate. In the healthcare organization, I can imagine an environment where there are many systems that operate. The system can be defined very narrowly or very broadly, getting back to your edge to cloud. So there has to be a configuration item in sort of scoping the communication between devices, and then you would set that up. I'm going to use the term as your access control list. Your access control list would seemingly define the scope of the system.
That's right, and I left out a concept. And so usually in systems that are that large, they're layered, and they're different networks that are all communicating together. So we have what's called a routing service in between all of these different networks. And these different networks can be in all different parts of the ship, with different parts of the hospital.
We RTI or we DDS secure?
DDS secure, and I'm hesitating because I'm not sure if the other implementations of DDS secure support forwarding your security information through the routing service. And that's a key feature because it allows DDS security to be used across this big layered architecture.
So by network, you mean the data buses?
Yes. Well, it's a little different. You have one network where everyone's connected directly, a LAN. But on that, DDS can be partitioned into domains. So each data bus is its own domain in the DDS world on its own LAN. So you can have on one LAN, you could have multiple data buses, and partitioning your data is very important because it means that you're not writing to endpoints you don't want to write to. Your system is partitioned. You only can talk with, you only do discovery with who you want to.
I'm not sure I'm buying that. Reason why I say that, and I don't mean to be rude, but it's the if I'm on a LAN segment, that's kind of a broadcast medium, so I'm going to see that traffic regardless.
But I use multicast. I don't use broadcast. And also, it's a function of our discovery service as well. And I can go into how that works, but it uses multicast first to see who's out there, and then it uses unicast directly to see if there's a match between endpoints. So it doesn't use broadcast. But you're right. Even when we use multicast, it does go to everybody because we use a well-known multicast address. It's just that it will only go to the domain. It will only care about the domains that match.
So how do you load balance the data segments when they're on the same sort of physical hardware infrastructure?
It doesn't matter to us. If they're on the same hardware, we'll use shared memory by default, but we can use a loopback as well. And they're just endpoints to us. And that's why it's so easy with DDS to move from different systems to the same system, even to different networks. Because
I mean, it's hardware infrastructure and the network infrastructure. So couldn't one data bus starve out another data bus?
Sure. Yeah, you still have to worry about that. But I mean, we could go down a rabbit hole. It has to do with the discovery process. I'll explain it after, if that's okay. So, but if you don't, and I know because the Zumwalt is a perfect example where with all of those different topics and all of those different endpoints, if they're on the same domain, it's too much discovery traffic going back and forth. Right. How am I doing for time? We're fine. So is your access to a particular topic protected? Is data on a particular topic protected? How? So will it be sent signed, encrypted, and signed? You have control over all of this. Are all protocol messages signed and encrypted? And it's not just your data, it's also the metadata that we care about and the discovery data that we care about. So you have control over all of this. Do you have a question?
Just scratching my head.
Okay.
And just clarify, a topic would be what, for example?
So if you remember on that other screen, a topic is just a data structure being communicated. And that's what we use in the DDS world to do. I hate to use packet, but it's sort of the packet you're communicating. Okay. An example would be you might have a flight controller app, and it's monitoring all these airplanes, and one of the topics is latitude and longitude. Another separate topic might be data going to an HMI, human-machine interface, giving control information, like the guy pressed a button. And this is a permissions file that basically talks about who's able to talk to what topic. This is a terrible example because everyone can publish to all topics, everyone can subscribe to all topics. I was going to actually show a better one on my PC. So the permissions document for each participant defines which domains it can join. So you can limit the domains a participant can join, what topics it can read and write, and tags are associated with readers and writers. And so this is the last slide, and just to summarize, with DDS Secure, it's a standard, it's interoperable. It's interoperable depending on your security with DDS systems that aren't secure even. So if your system is partially secure and theirs is not secure, at least those unsecured topics can be communicated. It's scalable because it supports multicast, it supports different domains. It provides fine-grained control of the security on your system. You determine exactly what topics are secure, who can read what topics, who can write what topics, and even within those topics, you can determine if parts of them are going to be secure or not. It's flexible because it has those plugins for encryption, access control, and authentication. Generic because it works over any transport. It's transport agnostic. And transparent. As I said, you don't have to change your application code to use DDS Secure. And that's it. So my card's at the front. If you have any other questions that you want to ask, feel free to come up and talk to me, grab my card, email me a question. Glad to help.
Okay, I have a question, which is, you talked about you need a certificate authority, you need, to manage the permissions and that sort of thing. How is that not a central point of failure? Can you distribute that in multiples? Is that idea?
Right, you distribute it after your system is fielded. So you don't, you use your certificate of authority to make sure you generate your keys ahead of time. But when you field your system, you don't need the certificate authority anymore if it's a static system.
How dynamic can DDS be with regards to adding new devices, expanding the thing? Because when you were giving some of the examples, it sounded like this is almost an enormous consulting opportunity, because I would consider the biggest security risk was making sure you got the permissions all correct and trying to debug what you got right, what you didn't got right, and doing all the audits to make sure all the right things are secured, which means you're pulling a lot of people to try to configure this all correctly. How dynamic can it be, or is it always a labor-intensive thing that you can't really easily add in new devices, have them go through a registration authorization process so that I can bring online 1,000 new devices onto this network and it'll work?
Right. So that's an excellent point. DDS is very dynamic. It's very upgradable if you want it to be. And even not including DDS Secure as part of the conversation, we have a lot of customers who don't want it to be dynamic for testing purposes. They don't need a dynamic system. They hardwire everything. With DDS, you could do it either way. You could explicitly say, I only want to go out this network interface. I don't want to use shared memory, I want to use loopback, etc. So that's totally up to the user. We have customers most customers do it dynamically now, but there's some customers, particularly in middle-ware, that do everything hard-coded. Now if you add DDS Secure to the picture, you're exactly right. It becomes even less dynamic, because once you establish your keys, it's sort of hard-coded the way who can talk to who explicitly, by definition. Yeah.
So one thing that wasn't really clear about the workflow involving those XML policy documents is who enforces the policy. There's a new participant, you're authenticating to some key distributor, which then checks the policy files for what keys they get. Well, if that goes on, how do you keep the key master from becoming the spy?
Right.
Or, or is it something else entirely?
Well, you have to have a key authority, a certificate authority involved. And the certificate authority comes with the public key. So that has to be involved in the process at some point. But you do that generally ahead of time while you're setting up your whole system. So I don't know, does that answer your question? I'm not sure if
entirely.
Yeah, I'm not sure if it does.
Yeah, I mean, if the whole thing, if the whole thing is done, is done during system setup,
Right.
Why do you need this XML?
It's a good way to configure everything using XML. You can do it programmatically too, but the advantage is that it is not programmatic, meaning that you don't have to rebuild your whole application. Like I said, if you want, you don't have to change your software at all. You just go into your XML file, turn on security, and then configure it using the governance file or the permissions file. But when you're doing that key exchange, you're right. At some point, you need that certificate authority.
When you mentioned the military applications, I would imagine like connected vehicles might be a great use case for this type of technology. Yeah, is there interest or applications in Detroit for this?
Yeah, I was just at GM, actually. I can't really say what they're doing. The automotive industry is very secretive. Like, for instance, we're involved in a lot of autonomous vehicles. But they won't even, I'll go in and I'll help them get things up and running. They won't show me their software.
Were you at Cruise when you were at GM?
No pictures, not even in the lobby.
Okay.
They put little stickers over my camera on my phone, and they're very secretive.
I was saying, I heard about that.
Yeah.
You had a picture of a Raspberry Pi on one of your slides. If I went to try this out, like connect a couple Raspberry Pis with DDS, is that something that's available, like a library somewhere?
Yeah, so I have a Raspberry Pi in my office, and I have DDM on it. You can download DDS for free from our website. You have to come to me to get the Raspberry Pi platform, but I'd be glad to do that. So just take my card.
Software libraries?
Oh yeah.
Okay.
Yeah, for DDS. DDS is really neat because you start with a language-independent file to specify your data. Like I talked about the aircraft topic before, longitude, latitude, all that. So you specify that data in what's called an IDL file. We have a code generator that takes in that IDL file, generates a whole working program, all the C code, all the .h code, everything you need. It even generates the Visual Studio solution file. So now you suck all of that into Visual Studio, hit build, it all builds the first time, and you have a working DDS application right from this little IDL file. So it's very easy to get up and running with it.
So why do we need UAE for the Raspberry Pi? Is it not easy to compile on an ARM core?
No, the eval I think just comes with a basic x86 Intel platform. So with us, we have to give you libraries to match your platform, whether it's ARM,
so you have
running
your
Linux.
RTI hat on.
What's that?
You have your RTI hat on as opposed to the open standard hat.
Right, RTI hat. Right. So the open standard, I don't know. Maybe you could go there also. We have a free eval from RTI, and it only comes with a few platforms. The other ones I could get you like for free. I mean, we don't source bomb our stuff. There's no license management. But there's also OpenDDS, which is the open source standard. I don't know. Maybe you could download that for the Raspberry Pi too. That's a good question.
So what does RTI sell? Are you selling services to help people put this together, or are you selling the software, the use of the software, or some combination?
Combination. So we sell the libraries, we sell services, and someone made a very good point that it is complex. It can be complex configuring all of this. I mean, you guys saw some of these applications have thousands of endpoints, and hundreds of different topics all communicating. And DDS is great. It gives you a lot of ways to configure your system to be able to efficiently communicate, but we also give you sort of enough rope to hang yourself a little bit. So service is a big point. We have a slide version of DDS. We're coming out, for instance, with ISO 26262 certification for cars. We have a DO 178C level A certification, which is used for planes. So that you pay for. And we have a micro version and DDS Secure, which we sell.
So I presume you also partner with other companies that provide other aspects of the solution, like either, secure the TPM platforms or the security manageability or configuration capabilities or stuff like that?
Yep, exactly. So remember I mentioned Infineon.
Okay.
They have the TPM solution. Mocana has their own open SSL replacement. And the great thing is, by the way, it just plugs right in because they have a shim layer that matches the SSL API. So it just works with our stuff. And then there's device authority for managing your certificates. And there's one more, I forget the name of it.
What you just said was, you said something was interesting. Were you part of the standards work where they decided to use the OpenSSL API as their official API? Is that what you're basically saying with OpenDDS?
They have, so OpenSSL is its own standard, it has its own API. That's what we use. And Mocana has their own sort of OpenSSL, but they have their own API. But they have a shim layer to translate between the two. So if you use their plugin and their shim layer, it just plugs right in.
Oh, so the OpenSSL API is not part of OpenDDS?
I don't know, that's a good question. Is that part of the DDS secure standard? Is it the OpenSSL API? I don't know.
The reason why I asked is I've been coming from EdgeX. And EdgeX has been, with their security concerns, they've been sitting there trying to figure out, okay, what set of APIs do we base off of? And if we're going to use an open source package, how much of that open source package sort of defines the API? Because when we've been finding in the security space, there's an interest in supporting third-party solutions whose entire business is meeting a degree of security. So a certain company will go the whole 9 yards and provide you a solution that some customers really care about, whereas others, and cost you a fortune. And then there's others that want dial back security, want some degree of security at a more affordable cost, or they want entire open source. But it is how to define the APIs, how far do we go between, the effort of the shim work.
Right.
We create an entire one and we just follow a nice standard. And so I was curious if you knew anything about that, because we're struggling with that on the EdgeX.
So I will say that a lot of people use OpenSSL because it's just out there. All of that security I showed you before, AES 128, AES 256, GMAC, Diffie Hellman, all that comes from OpenSSL. And it depends on the version. We're about to upgrade to 1.2-N or something. But I will say that a lot of our customers don't think that's enough. For instance, they want FIPS certification. Then they can go to Mocana. And you'll notice that even though Mocana has their own API, they created that shim layer because there were enough people who use the OpenSSL API. So maybe that helps you. If you go with that, enough people are using it also. The OpenSSL.
Yeah. Interesting approach.
Any other questions?
What does OMG stand for? Did you mention
Object
that?
Management Group. Object Management Group. Yes.
Oh, okay.
You could look it up on
Oh my God. Also, oh my God.
Yeah. They were heavily involved in a lot of cell phone stuff for a while. They're just one of these standards groups.
Okay.
Right. And you could look up OpenDDS there if you're interested in that, or they'll list all the DDS vendors that are out there.
So I don't know if I'm way off. I'm trying to connect the whole discussion to something more concrete where I come from. So if I have a personnel record, right? So what was the term that you used? Topic?
Yeah.
Right? So say a person's identification, like the employee information and the social security and a whole bunch. So that's a topic, right? So it's stored on an Oracle database.
Yeah.
Can you explain to me how this configuration would secure that data layer? Because in relational database can get database row level and transaction level security hardening and prevent SQL injection. So I'm trying to figure out where this is in the data layer too. So I'm having trouble figuring out if I went with this solution.
Right.
Where am I? I'm losing it.
So generally, first of all, I'll say that we're not typically found in applications that are like just SQL databases. It's usually where there's, so there's sort of 5 requirements that we have that we go over with our prospects to see whether we think DDS is a good fit.
Okay.
One is, do they need performance? And we're talking milliseconds or microsecond performance. If they're talking in that range, that's one of the check marks that says DDS might be a good fit. Are they connecting a lot of different devices? That's another check mark.
Okay.
Are they, what are the other ones? Their speed. Do they need it to be rock solid? It's mission critical. It could be anti-lock brakes. You're connecting a whole car. That's another check mark. So with a hospital record system, usually you don't need that speed. So it's a different type of application. Now that being said, we also have a database integration service. So DDS can talk with databases live, read and write from Oracle, from Microsoft, as long as they're relational databases. Then we do in hospitals, we do exactly that, because we talk with all of those instruments in the hospital room, right? A pulse oximeter and a heartbeat monitor and all of that. So some of the topics being transferred are about those. They go to the nurse's station, and now maybe they get slimmed down into one topic that says patient Jones, heartbeat regular, and that goes into their relational database.
Yeah, because I know one of my physicians that I see gets really frustrated, and sometimes for a physician to practice, though it's not mission critical.
Right.
I mean, if you can't pull out the history, right, like that, it's not going to work. So
Right.
In a way, it's not mission critical, but relational databases would be too slow.
Right, and that's a huge problem. And my sister actually works in that field,
Yeah.
and they're horribly inefficient.
Yeah,
Those systems.
it's so bad. So
all the money that's been poured into it, and they still don't have it right. It's
and
just
not only
crazy.
that, it's proprietary. They don't have standards.
Right.
And they are having this market share, and they're locking up all the data, which is very frustrating because it's not agile at all. It doesn't work.
Right, and by the way, that happens in the hospital room, operating room too. All those different devices, they don't want them to talk together. They want you to have to buy all GE devices or all Philips devices or all whatever devices.
Yeah.
So it's sort of a tough battle.
Who are the competitors for DDS with regards to protocol-wise?
So TCP, probably the biggest one. Homegrown, that they would use TCP or something else. MQTT is another one. RapidMQ is another one. Some of them use brokers, meaning there's a central server, so you have to be careful. They're not really meant to handle as big a system as DDS. And DDS has a lot of configuration settings, like I mentioned before, enough rope to hang yourself. It's called QoS, quality of service. So for instance, with quality of service, you could set it up for automatic failover. So you have redundancy built into DDS, it'll automatically fail over. You can have durability. The late joiner comes in, he gets all the messages he missed because he was a late joiner. It's built into DDS. Live
These are
DDS.
cool features. You should have brought those up earlier.
Well, my DDS presentation that I usually give is longer than what I did today because I wanted to focus on DDS security.
Yeah, okay.
But no, there are a lot of other neat features to DDS besides what I showed.
So how does this, sorry, am I?
I was just gonna say, I mean, we read so much about, insecure IoT deployments, whether those are, webcams and DVRs or, kind of connected infrastructure, smart infrastructure, HVAC systems, what have you. What is the impediment to having folks who are producing manufacturing products like those from implementing something like DDS? Is it really just education about the existence of this technology?
Mm-hmm.
Yeah.
Well, what we try to do is, as I said, we're part of a lot of these consortiums.
Yeah.
Like a big one is the IoT consortium. And we're a big part of that. We're part of their reference framework. We're also part of ROS, which is Robot Operating System. We're underlying their communication architecture. So we get a lot of business through those two consortiums.
So, sorry,
Security domain-wise, does DDS sort of only support the notion of one secure domain, or can you have multiple security domains working over this?
You can have multiple security domains. You determine which domains are secure, which aren't. You can also, so remember, when you're communicating between domains or between networks, you use that routing service, which passes all your security information. But not only that, that routing service can filter that information. So you could say, I only want half of this information to go through to the other side. I don't want the patient's name to go through, I just want heartbeat to go through. It will strip out the patient's name if you want. It could even translate between protocols. So it could turn DDS into TCP, for instance.
So that routing service can bridge security domains?
Yes.
Okay.
so the other thing that is boggling my mind, so we are going to the cloud, right? We have Google, we have Asia, and we have AWS, okay? So they are talking about having these Azure Edge, right? And I'm sure the equivalent, I don't know, I can't remember.
Microsoft.
Yeah, Microsoft, right? So it's IoT, right? And you can plug, take care of everything. Where's the security? In the cloud? Or do they use your service? Or use this concept?
I don't think it's built into Microsoft, any of their protocols.
So are they building this security that you?
Well, probably they're just using some of the standard stuff that's out there, like TLS or DTLS.
And you said what?
Well, all of it is based on, remember I said the X509, which is that whole certificate system. They're probably using something like that, but I don't know. And they're using encryption, I'm sure.
Yeah,
that's a huge
it's like a
thing.
secure cloud. I mean, they're not saying we're going to give you a hardware platform to deploy your device on. They're saying we're going to make it turnkey for you to securely deploy the back end of this system and to have encrypted comms to and from, and to make sure that your server is properly configured and hardened and so on. But
so
if you create an insecure, if you're building an insecure device that uses crappy software, that's Microsoft.
they can sell it to you. I mean, the back end will be great.
Right, but the devices that you're hooking up to the system,
Yes,
that is DDS.
it could be.
It could be.
Sure. I can't say that every device out there that could use DDS is using DDS. It would be nice for me, but.
I don't know the Azure system much, but like for Amazon IoT, they use MQTT, which is a competitive communication, but first they secure it in a TLS channel.
Right.
So you have certificates and you have
Right.
keys that are involved in getting a secure channel, and then they just run MQTT through the tunnel.
Right. You have options, I think they can select it. For Microsoft, they give you options, because I don't know what they are, but in the configuration, that's not the listing. That's why the blockchain, or I came away thinking, oh, I'm not sure I understand it correctly, but what was suggested is some kind of a standard where every hardware device would be physically edged with that, and you cannot reverse engineer the identity of it. Anyway.
The blockchain, I think, might apply to your hospital records idea. I mean, you want to keep track of every single time someone touches a hospital record.
A device that you, a Raspberry Pi, that installing, it has something that would implement the blockchain concept. I'm fuzzy. That's what he's suggesting.
We got a break.
Okay.
This is a big hand for David. That was a great presentation. And great questions from you all. Thank you so much for coming out. So the video of this is going to be online, and I'll post a link to it to the meetup. We'll be posting information on next month's March Security Fix meetup. Location and agenda TBD. As always, if you have topics that you are curious about and you would like to see discussed, message me on MeetUp, email me, paul@securityledger.com. You've got my mobile, I think, you can text me. I'm a really smart guy, Jeff's a really smart guy, but we always need new ideas and things. We want to know what is interesting and occupying your brain, because I'm sure you're not alone, and we can use that as the basis for scheduling our next talk or what have you. Okay? Thanks so much, and thanks to WeWork. And thank you. Yes.
Yeah. Well, I think round after another.
But I agree. No debate. I just.
At the end of the day, convert protocols, or you take your data. My guess is yes.
Good.
Nice to meet you.
There's a lot of interest in having that the autonomous vehicles enable things now. We don't want data going around that. Let's have a product like that.
I was just at Cardiac and they're in Michigan, they're interested in tanks.
And we're always hiring.
Going outside of TDS.
Fortunately, whenever it's startups, we're not too much on the security side. We should probably do better.
So, I think we did it. The problem for me is that Cardiac discovers any direction.
Okay. Is there a special team for 60 or?
What data are you actually, what is the configuration of the data? That would take forever. But now we're looking at these are my grades, those are, he isn't my grade, he isn't my grade.
That's the physics. Yeah, we have this thing called the process, which is like, you basically build a robot, right? How do you control it to get the absolute best results that you can? And that's one of the ways that RTI succeeds is that hardware that goes into your IC is pretty cheap, like inexpensive manufacturing methods. But we put a lot of effort into controlling it just right. How fast you roll motors, how long you wait, how fast you roll laser power do you use, what pattern do you draw. That's like this weird combination of software, chemistry, physics, like we have several fluids, dynamics, yeah, it's crazy how
Yeah, absolutely.
Yeah, I do a lot of printing that we get unlimited printing, so thank you. Printed like big old heavy base tower. We're in Somerville, so they walked here.
You know, this could relate to Ajax too, couldn't it? In their case, in their product, it was an open source version of these things that made extra features.
So that also kind of
We've sort of discovered that
there's a lot of people working on the same area of problems, coming up with solutions.
Step.
10 years from now, I think Brad is right.
Yeah, they didn't help it, but
who remembers?
Okay, first off, what is it?
But there was 10 years where there was no balance. And we're just at the beginning of that 10-year balance. Right. We're not the end.